Hello, in this video we are going to examine the exponential decay function and its use in calculating decomposition. As we've learned in class, decomposition is the physical and chemical breakdown of dead plant, animal, and microbial material. The process of decomposition releases carbon into the atmosphere and nutrients into the soil to be used by plants and microbes. Decomposition is an important forest process. In class we talked about measuring decomposition by calculating turnover rate and by using exponential decay functions. Today we will only talk about the exponential decay function and go over examples you might see on a quiz or test. As you may recall from class, the exponential decay function we are interested in is shown here. b sub t equals b sub 0 multiplied by e raised to the negative kt, where b sub t is the biomass at time t, b sub 0 is the biomass at time 0, k is the decay constant, and t is time, which we usually measure in years. We commonly solve for this proportion though. B sub t over b sub 0 equals e raised to the negative kt. The exponential decay function can be used to calculate the decomposition rate of a bag of litter or a wood stake left in the forest for a known amount of time. You can also use it to solve for the proportion of original biomass remaining after a set amount of time. Let's look at some potential problems that you might encounter in this course. Here's the type of problem you might see on a quiz or test. A wood stake was collected from the forest floor after 3 years. When put in the forest, the stake weighed 67 grams, and when collected after 3 years, it weighed 21 grams. What was the decomposition rate? So what we're trying to find out in this problem is what the value of k is, as we know what b sub t, b sub 0, and t are. The first thing we'll want to do is to write our equation with our known variables. First off, we know that after 3 years in the forest, the stake weighed 21 grams. Let's know that at time 0, at the beginning of the experiment, the stake weighed 67 grams. We don't know k, but we definitely know what t is. You can see from the problem, t equals 3. So all we need to do now is solve for k. And to do that, we'll want to be able to take the negative k3 out of the exponent. And to do that, we just need to take the natural log. And if we do that to one side, we have to do it to the other. So if we use our calculator, we can figure out what the natural log of 21 divided by 67 is. That gives us an answer of negative 1.16 equaling negative k3. From there we can use algebra to solve for k. The first thing we'll want to do is divide each side by 3. And we can use our calculator again to divide negative 1.16 by 3. It gives us an answer of negative 0.39, which equals negative k. And that might seem okay that we have the answer there, but not quite. We want to know what k is, not negative k. So having a negative k is like having a negative 1 multiplied by k. So all we have to do is divide each side by negative 1. And to do that, we just take negative 1 by each side, which will give us 0.39 equaling k. So we know that after 3 years, our wood stake had a decomposition rate of 0.39. Another thing we can solve for is original mass remaining of litter. So let's do another example. How much of the original mass of a hazelnut leaf would remain after 2 years if its decomposition rate factor was 0.27? Well, now this time we are trying to solve for bt over b sub 0, the proportion of the original mass. And we know our k and our t. So let's just write out what we need. Well, we want to know b sub t over b sub 0, and it will equal e to the negative k, which in this sense is 0.27 multiplied by t. In this example, t is 2 years. So all we have to do now is solve for our proportion. And to do that, the first thing I like to do is take the negative 0.27 multiplied by 2. So we get out our calculator. We'll do a negative 0.27 multiplied by 2, which gives us an answer of negative 0.54. But we still need to raise e to that. So once again, we just use our calculator here. We can take e raised to the negative 0.54, which gives us an answer of 0.58. 0.58. So this means that after 2 years, our original hazelnut leaf had 0.58 or 58% of its original biomass remaining. So those are just two types of equations that you might see on a test or quiz in this class. And the exponential decay function is an easy way to calculate decomposition rate and original biomass remaining problems. After watching this video, you should be able to solve these types of problems that you might see on a quiz or exam.